Hi everyone, Mr. Rodriguez here again. Today we are going to be starting a new unit. We are going to be talking about volume. Previously we have talked about area. Area, if you remember, is basically the space within a two-dimensional shape, or two-dimensional object. So you could have a triangle or a square, and area is all the space that's inside, right? Volume is similar, but volume relates to three-dimensional objects. So if you imagine all the space that is inside a cube, that's going to be in 3 dimensions now. It's related, but different than area, right? Because area is kind of the amount of space that's kind of in a flat surface. So before we get into volume, I do want to talk about three-dimensional space more generally. So our objective here is, for this lesson, is students describe properties of points, lines, and planes in three-dimensional space. So basically you're going to be talking about these geometric objects and how it relates to 3 dimensions. So first I kind of want to give you a basic outline of what these different geometric objects are. So let's start with a point here. So if you have a point, it's basically just a dot, and really a point actually has no dimensions. It doesn't go in any directions at all, right? So I know it's a little hard to think about, but a point has no dimensions at all. A point does not have any area. Even when we draw it, it might kind of look like it has, right, some area, but that's just the limitations of our ability to kind of represent that concept. And let's look at now a line. A line now is a one-dimensional object. Here we have a line, really just, it goes in kind of 2 directions, but it really just kind of occupies, right? It can only go either this way, right, or that way. And you can imagine if you were somehow like walking on a line, you could not go like over here or over here. You're just stuck along this kind of one series of kind of points. So it is one-dimensional. Now, if you take a shape like, say, a square, so if we say 0D, 1D, and now a square would be two-dimensional. So why is a square two-dimensional now? Well, it's because, again, you have a line, so you can kind of imagine a square could kind of go this way, right, and that way in some sense. But you'll notice it also goes in this direction, right? So you can see, because of this, a square is a two-dimensional object. So now a three-dimensional object is basically just anything you would encounter in real life. So, the pencil you're holding is in 3 dimensions, right? So three-dimensional object basically, right, if you imagine, say, a cube, right? A cube would, like if we look back at our square, right? A square only goes in these kind of 2 different directions, this sort of kind of like up, down, or right, left. Whereas a cube would kind of, if you imagine, it would kind of, if you put a cube on a piece of paper, it would kind of come towards you, right? It's kind of hard to draw, but if you imagine a cube would kind of somehow like come like up in a way, right? So a cube is an example of a 3D object. Another example is something called a plane. You could kind of imagine a plane almost like a piece of paper. So, when you draw it, it kind of looks something like this. Whoops. That's a little sloppy. Let me try again. So a plane, you kind of have to imagine, it's kind of like a piece of paper. And a piece of paper is really a 3D object, right? So you can kind of imagine a plane is almost like this piece of paper. And you kind of have to imagine that, when you draw it, kind of like this side of the plane is a little kind of closer here, and then this side is farther away. Um, Obviously, what I'm working with here, the screen I'm writing on, is 2D, but you still have to figure out ways to kind of represent 3D objects. It's kind of like if you look at a painting, right? Technically, a painting is all 2D, but a good artist, right, can make things appear closer or further, so you can kind of imagine that it's 3D. That's kind of the same thing you have to do here. You kind of have to imagine that this is really a 3D plane, right, and that this bottom side is closer to you and the other side is farther away. So a plane now can have all sorts of things on it. A plane could have lines on it, right? It could even have a line kind of go through it. It's a little hard to draw, but like you could imagine that a line kind of goes through a plane. Say it goes through the plane right over here. You kind of imagine that this part down here is under the plane and this part is above. It would almost look like if you jammed the pencil through a piece of paper, right? Part of the pencil is below the paper, the other part is above. So it's kind of just some basic things about planes. So let's look at some kind of examples here and draw them out, and hopefully this kind of concept will become clearer. So let's look at number 1 here. So it wants us to draw, it says 2 points P and Q, determine a distance PQ, a line segment PQ, a ray PQ, a vector PQ, and a line PQ. So basically, if you were to draw something kind of like this, oops, it's supposed to be a Q. So you can imagine that, right, it says a distance PQ, right, a distance PQ. Well, we have that. It's just the distance from P to Q. A line segment PQ, right? The line segment PQ is just the line that goes from P to Q. A ray PQ, that's a little different. So a ray PQ, it would start here at this point, P, and then it would actually go forever in the other direction. That's what a ray is, right? Different than a line segment. A vector PQ, we haven't really talked about vectors, but a vector is basically kind of like a ray that has, it's a line segment, right? And it has kind of both a direction and kind of like a length, if you will. So you can imagine kind of a vector could be like a line that kind of goes in any direction in 3D space. Kind of like if you just pointed your pencil somewhere, it's going in some specific direction. But that's a little harder of a concept to get. And the line PQ. So the last one here is a line. So a line, again, goes in both directions. And let's look at number 2 here. So it says 3 non-collinear points A, B, and C determine a plane ABC, and in that plane determine a triangle ABC. So what non-collinear means is just that those points A, B, and C don't all fall on the same line, right? So for instance, if you had kind of point A, B, C, you could kind of imagine that if you can form a line like this, kind of sloppy line, but you can imagine that doesn't really show you a plane, right? That could just be a line. So when it says three non-collinear points, A, B, and C, determine a plane, that means it's something like, if you imagine if this is in 3 dimensions, it's kind of something like this, where you can make a plane out of it, right? So none of these points are on the same line. So it says, given a picture of a plane below, sketch a triangle in that plane. So you can kind of imagine it would have to look something like this. You can kind of imagine, again, it's kind of like just drawing a triangle on a piece of paper, right? The paper is like the plane, and then what I just drew there is like the triangle you're drawing on it. And, you kind of have to imagine, depending on which way you're facing the paper or how you're holding it, it could look different from different perspectives, right? Let's see. And lastly, we'll do number 3 here. So 2 lines either meet in a single point or they do not meet. Lines that do not meet and lie in a plane are called parallel. Skew lines are lines that do not meet and are not parallel. So this is an important kind of concept here. So let's take a look at these examples. This will help to you guys to understand that concept. So it says sketch 2 lines that meet in a single point for A. So these would be lines that are perpendicular, right? Or not necessarily perpendicular, they just, here they just intersect, I'm sorry. So you can imagine just something like that, right? Whoops. Something like that. You see how those 2 lines intersect? Perpendicular lines would look something more like that, right? Because they form a right angle. Either of those are examples of lines that meet in a single point. For B, it says sketch lines that do not meet and lie in the same plane. So lines that are on this plane, on this piece of paper, and never meet. Well, if you remember, the only thing that could be true of are parallel lines, right? So lines that are parallel to each other. If even one of these lines is, slightly, curved a bit, then they would meet at some point and they wouldn't be parallel. Now, this is an important concept here, skew lines. So in 2D space, any lines that never meet must be parallel. However, in 3D space, that's not actually true. The reason is because you could have something like this. Imagine I draw a line that goes through the plane at a certain point. Again, that concept of like a pencil jamming through a piece of paper. And then you could also have kind of a line that just kind of goes on the plane here. So you kind of imagine like this line is kind of on the left side of the paper. This is a little more kind of on the right, and it's going through. And notice that these lines here are not parallel, right? But they'll never actually touch each other. So these are called skew lines, and it's only possible in 3D space. So that's it for the examples I want to do. And then for the problem set down here, you'll kind of work on these problems. They're more conceptual, so you kind of have to imagine, visualize what lines are, how they would look in planes, how planes might relate to one another. This worksheet is very visual. It's kind of just developing your kind of ability to visualize things in your mind. So that's it for today's lesson.